Okay, this I showed you online. I thought it was interesting. I have more examples where I use logs. I use logs all the time, but what's funny is that one of the doctors I work with, I always use natural log, the LN, if you watch the video. Because I'm a mathematician and I got my degree at Georgia Tech and I worked at West Point in the Army Research Lab. Those are engineering type jobs, and we use E and natural log. But in medicine, you always use log base 10. And so sometimes he'll ask me like, "How did you get that?" I'm like, "Oh, I'm switching from log base 10 to natural log." So he's unfamiliar with it, so it always looks weird to him when I do it. Some things won't change though. So. Okay, so this one. This one's an interesting one, and maybe you guys will get this the first time, but my students, I really focused on this in a Calc 1 class a number of years ago. They all turned out to be high school math teachers in the end, and they had a hard time with this. They were looking at a graph like this, and they were asked to draw its slope. So this little f prime up here means slope. So sketch the graph of slope. So what I thought I'd do is I'd write it out as step by step, what you're supposed to do. It's going to take you 2 seconds to do it once you figure it out. But this is an important thing, actually. This is an important skill because this is useful. This is one of the things that actually I do see. Here's a graph. The first step is to identify where the curve is increasing and decreasing. Look at me, tied up in the corner of shame. Somebody said, don't move away from the mic. I'm trying. So if I walk away, somebody remind me by pushing me back, right? Should I put a dunce hat on too? I feel awful because I like to walk, but it's better, I think. I listened to it and like my voice was going in and out. So you see, like I put arrows on this. Whenever the roller coaster is going down, see that arrow, the roller coaster cart? Think of a little roller coaster on this thing. That's where it's decreasing. And I identified the places where it's flat. And here it's increasing because the roller coaster's going up. There it's like the flat place on top is right where you hang. And then whee, you're back down again. So that decreasing is whenever the roller coaster cart's going down. Increasing is that moment where your heart's going up, 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 up. Those things were really fun when I was young, but I don't know, I get sick now. All right. So wherever it's a flat, make an X on the x-axis, make a mark, like a treasure map mark. Make a treasure map mark on the x-axis. Those are important points. They're actually called critical points. But like make a little X on there. Wherever it's decreasing, make the slope graph less than 0. Less than 0 means below the x-axis. So notice that I here have siphoned off. It's decreasing here and up to here. So right in this range, it's decreasing. So my f prime graph in those ranges, see here it's decreasing between these two lines here. There I've made a purple graph. I didn't make it any shape. I just put the purple graph underneath the x-axis. That's the important thing. It has to be underneath the x-axis. So far, so good? What about you? Good? What's your name? Domingo. I'm going to pick on you a little bit. So now never tell me your name. But then I'll nickname you if you don't tell me your name.
Does it matter what way the language?
It kind of does, but it doesn't have to be perfect. I just kind of, it's a multiple choice thing. I can kind of see the answer on one side. I'll show you in a second, right?
What is the purple line represent?
It's the graph of the slope, right? So the slope here is negative, right, because it's a decreasing function. So I know that's below the x-axis. So I got that. That's the nice thing about PowerPoint. I can remove my defacement, and there it's gone. And wherever it's increasing, that's step 4, I made a little increasing lines to give me a kind of a picture. That's where the slope is positive. You're going to make the curve above the x-axis in that region. So it's not Graph Appreciation Day. That's coming up. Are we going to celebrate it? We'll get pizza and cake. We'll invite Ted Williamson's class over. Let's do that. It's Graph Appreciation. We'll have nice graphs around the room. We'll do it. Want to do it?
Yes, the day.
I'll have to pick a day that maybe like day after test, and that'll be our quiz the day after test. What do you think? All right, it's set. All hundreds if you make me a good graph that we can post up. So I will knock on their door and invite them over for pizza. We'll do that. And then we'll challenge them to a basketball game. I saw them, they looked short. I think we could take them. Dr. Williamson was the tallest. But I think he's retiring after this year, so I think I got him on the cardiovascular health piece. I can take it. All right, so I think my purple graph here, I'm going to remove everything. That's what it's supposed to look like, the slope. So purple curve is the answer. So I looked at these and I actually should snapshot the purple curve so you can see it. But it's not this one because the purple curve was underneath and then went above and then it was underneath. The only one that's underneath, goes above and underneath is this one right here. None of the others do that, right? And so somebody asked me, was it you that asked me? Like, does it have to be perfect? You asked me, right? Does it have to be perfect, right? It doesn't have to be perfect. You see, like, there it was slanting down. So what? I got it. It's pretty close. Okay, we good? That one?
Yeah.
So I didn't draw it perfect, right? It's supposed to, here you see the slope is going to 0, so really that purple curve should have bent towards 0, but wasn't making it perfect, just trying to get the answer right. As I was doing that, I was thinking that too. I'm not making this look nice. I just know that there's going to be one that's obvious. Why would they have one that's almost right and then they don't do that on WebAssign? That should teach you a very important lesson. That is, when I have a real problem and I'm supposed to do something, I do it to the specs of that problem. The specs of this problem was to pick something out of a multiple choice. So I do it to the specs of that problem. And I can't help it. I'm not going to lie to you. Okay. Again, same problem, same methods. Find the tangent line. Calc students at Georgia Tech that tested out of all kinds of AP courses called this, she's making us do it the long way. This is what it's called, the long way. But it is what's the most useful way for biology because in general, you're not going to get y equals x squared. You're actually just going to get data. Data is all you've got. So again, we'll be on quiz again next time. I'm going to do this step by step. We just had this on a quiz. Some people tell me they feel uncomfortable with this. You won't after a while because you get it. Take a quiz. The quizzes are worth so little. So every time you take a quiz, you get a chance to like fail at some pieces of it, try again. Fail a little piece, and then eventually you converge to perfect. By the end of the semester, my students get 100. I start grading, and grading's easy for me at the end of the semester. You'll get there. Step 1, identify the first point and the second point. The first point's given to me. Do I give you the y value? No, I don't give you the y value. So I don't like that WebAssign does it. You have to get that yourself. How do you get that y value? You plug it into the formula. So you plug it in into x minus x to the 5th. If you're taking your notes, put a little note and say the rest will be on the video. This will be there. So I got my x1, y1. x2, y2. Well, x2 is a, and y2 is found by plugging a inside the formula. So I plug a into x minus x to the 5th. We were confused about that on the in-class assignment, right? So that's not a number. It's actually just a letter that you're plugging in. So that gives me my x1, y1, x2, y2, which is scooted down to the bottom so I don't forget what they are. And new, required on quiz. I actually want you to draw what you're doing. Because when I saw in the in-class assignment, people were like confused, like what is the second point supposed to be? Is it supposed to be 5? So now I know like there's a gap in understanding there. So I want you actually to draw the original curve. You can go up here. I'll have the laptops out here. You can use that math web or whatever it was. I already forgot. There's that curve. I drew it on Wolfram Alpha, but those two things have to be there. You have to tell me what's the x and what's the y. I must have those numbers too. You can't just draw me a crappy graph. That's actually important. My medical friends actually made me learn that the hard way. I used to draw the sloppiest graphs for our papers, and they used to be back and forth. And one time they called me like, serious, Di, we need to have a talk. And I thought, oh my God, what happened? Like your figures are mislabeled. And I thought, oh my, they're really crazy. These guys are crazy. But I realized like you're trying in medicine, you have to make your point very clearly and quickly, and everybody's got to get you. Like it's not like math where we have, 5 minutes of the first part of the talk you understand, the rest you don't. That's not the way it is in medicine. So I got kicked in the butt hard for not having label graphs. So now I import it on you. Make sure you have label graphs and they look clean. So I need to know where your markers are. And I want to tell you that a student actually got everything right in pre-calc, except didn't label a graph, and it says full points off on the rubric if you don't label your graphs. And I marked them down in the rubric, and I said, no, it's important. You have to label the graph. So don't be that student. There's my x1, y1, there's my x2, y2, and I just drew a line through the two of them. You're looking at the slope of that line through those 2 points. And what you're going to do is slide the second point right here. I was tempted to walk over there. Slide that second point, the A, it's going to slide back over to 1 after you finish. That's the goal of this. So now you compute the slope. That's what you did on your in-class design or your work today. This should be, second time around, this starts to get easier. y2 minus y1 over x2 minus x1. Plug and chog. Well, I'm not quite sure I know how to factor 1 minus a cubed, but I can bet you there's going to be factor 1 minus a in there. Right? Because it's a textbook problem. It's difference of cubes. Don't remember it? There it is. I think the best way to learn Math 100 is right in calc. Just take calc all at once. Do it all at once. Anybody who needs to shore it up, because you already got it before in high school. Why take it again? No point, right? Just learn it while you're doing something else. So then you see this is difference of cubes formula. If you don't remember it, that's what it is. If you don't remember it, know that you would have to factor out something like a minus 1 down here. Otherwise, they won't cancel, and you know that it's supposed to cancel. And start going backwards and saying, I know an a minus 1 must factor out, so what must the leftover pieces be in order, just guess, and then see if you can come back to it. Oh, look at that. I put a parentheses around it. Remember when you were little and didn't put parentheses there? You don't do that anymore, do you? Yeah, you put your parentheses up. You're going to cancel the whole thing, that's why. Those two cancel. Remember on the last time I actually showed you that 1 minus a and a minus 1s are negatives of each other, so they cancel, they just plop a minus sign in the front. See what I mean about learning algebra in context? If you don't, it starts to stick in your head after a while. You're using it for something else. There it is. And then you slide, let a slide to x1. That's the limit stuff. I put up my math talk, but you're sliding, right? You're letting a, now after you do the cancellation, you can let a slide to 1, and I get minus 3 as my slope. Now you need the b, y equals mx plus b. y1, x1, m equals minus 3. There it is.
I have a question. I don't understand how you became 1 minus 8.
That's called it's a formula. So like difference of squares, there's a difference of squares formula.
We factored a out after
Where's a cube? Did I get a cube somewhere?
Well, it went from a minus a to the 5th to 1 minus a to the 3rd. Right, from the green to the black.
Oh, did I not factor correctly here? A. Yeah, you're right. It would be difference of squares. That's even easier. So let's put the correct thing here. Wait, maybe 2 wrongs make a right, because I think I graphed both. So this is nice. Don't capitalize. Oh, it's actually a little messier. I thought it was going to be easier. So I'll tell you how it's messier. So that's equal to a times 1 minus a. Now you'll know difference of squares. There's no way to hide from it. 1 plus a divided by times a squared. And then we have the a minus 1 down here. And now the a minus 1s and 1s cancel, and I'm left with scoot this over. So the correct answer will be minus a times 1 plus a times 1 plus a squared. And let's see, if I put in 1 in here, 2, how does this change my answer? One, 2, 1 plus 1 is 2, 2, 3. You get minus 4, right? Correct? You have to watch my arithmetic. That's my weakest point. So let's put that in. Okay, we're going to go with my minus 3 answer just so I can go through the steps with you. So at this step, you know, instead of minus 3, we would use minus 4, but we would go through point slope formula. And I guess it was not that bad. Minus 4 and minus 3 were not that off. So I couldn't even see that it was incorrect. But you would take your line and graph it with your original curve, and you should see that it looks like a tangent line, just like what I showed you on that math web earlier, that you should see that it's one and the same. Okay, questions on it?